Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hello everyone, in this video we're going to talk about how we can graph tangent and cotangent functions. So starting off over here in white, over here at the left, we see we have our two essentially parent functions, but we've added an a and a b. So we have y equals a tangent b of x and y equals a cotangent b of x. So a and b represent the same thing. A is going to have our vertical stretch or shrink. So if a is greater than 1, that's going to be a vertical stretch of the parent function. And if a is between 0 and 1, it's going to be a vertical shrink. Now for b, we see b as our horizontal stretch and shrink. So it's kind of opposite there. So if b is between 0 and 1, it's a horizontal stretch. Because remember, we're stretching by a factor of 1 over b. And so that would be, in this case, if b is 1/2, we're actually stretching by a factor of 2. So that's where it kind of makes sense. Then a horizontal shrink is when b is greater than 1. So let's say, for example, b is 4, so it would actually be a horizontal shrink by a factor of 1 over 4. Now, what b does is it also changes the period of the graph, so we'll have to take that into account as well. So 3 important things to know: the period and where our asymptotes should be located. So the period is going to be pi over the absolute value of b. The vertical asymptotes for tangent should be just odd multiples of pi over 2 times the absolute value of b. And the vertical asymptotes for cotangent will be multiples of pi over the absolute value of b. So here's what our graphs will look like. And once again, just like with sine and cosine, we're going to pick 5 key points, and that's going to help us be able to graph these functions. So the first key value is our x-intercept. So if you notice, for tangent, our x-intercept is at the origin. And for cotangent, our x-intercept is located at pi over 2b, comma, 0. Now the next 2 points will be x values where asymptotes occur. So for tangent, we have positive and negative pi over 2b. And for cotangent, we have pi over b and also the y-axis, which would be x equals 0. So there's 3 points, and then the next 2 points are going to be x values halfway between the x-intercept and the asymptotes. So for tangent, we're going to have pi over 4b, positive and negative. And for cotangent, we're going to have pi over 4b and also 3 pi over 4b. So the key for graphing both tangent and cotangent, once we evaluate or once we recognize these 5 key points, is that at each halfway point, the value of the function is either a or negative a. So essentially we're trying to graph 3 points: the x-intercept, and then a and negative a, and that's going to give us our graph. So we're going to look at 2 examples, one of each. So for example number 1, we're going to graph a tangent function. So it says graph one period of the function, g of x equals 3 tangent 2 of x. So a would be 3 and b would be 2. So this is our tangent function, so our x-intercept will be at the origin here. We see that a is 3, so we could go ahead and label this as positive 3, and our point on our y-axis and the negative would be negative 3. So the period is pi over absolute value of b, so the period is going to be pi over 2. And our asymptotes are going to be located at positive and negative pi over 2b. So this is going to be let's say pi over 2 times 4, so pi over 4, and also negative pi over 4. So let me draw those in there. So let's put this as pi over 4. Let's let this be pi over 8, negative pi over 8, and negative pi over 4. And let's draw vertical asymptotes here. So there would be 1. Let's make that a dashed line, and we'll make it white. And then we'll copy that and bring it over here to negative pi over 4. Okay, so those are our 2 asymptotes. And so now we want to identify our halfway points between our x-intercept and our 2 asymptotes, and that would be at positive and negative pi over 8. And so now we can graph our point up here at positive 3 and also our point down here at negative 3. So now we just need to draw our graph in here. So here's where it helps to have an idea of what our function should look like, just like this one. So we'll go down here and try and do the best we can. So we know we're going to approach our asymptote, but then we're going to be coming out, right, and going through our points here, and then back up this way. Okay. All right. So could have drawn that a whole lot better, but that gives us an idea of where those points are located. All right. So now let's think about the transformation. So what happened? Well, a was 3, so we had a vertical stretch by a factor of 3. Vertical stretch by a factor of 3. And then b was 2, so we had a horizontal shrink by a factor of 1 over 2, or by a factor of 1/2. Okay, so there's our example number 1 for graphing a tangent function. All right, now let's go down here for cotangent. So we have g of x equals cotangent of 4x. So we don't see an a value, so a is 1 and b is 4. So our period in this case is going to be pi over 4. And now let's locate our asymptotes. So we see that we have y-axis, because we're graphing a cotangent function, so the y-axis is going to be one of our asymptotes. So if I copy my line down here and bring it down, we could just basically put it right on top of our y-axis. And also we're going to have an asymptote at pi over b. So this is going to be at pi over 4. So asymptote at pi over 4. Okay, so now let's label our graph here. Let's put this at pi over 4. So then let's make this pi over 16. This would be 2 pi over 16, so we could call it pi over 8. And with this one is going to be 3 pi over 16. Okay. All right, now we noticed that a was 1, right? So we could go ahead and label y-axis 1 and -1. And now let's look at our x-intercept. So x-intercept, let's add our other asymptote in here. So pi over 4. We'll line it up with that one if we can. All right, pretty good. Okay, so now x-intercept, pi over 2b, comma 0. So pi over 2b, well, b was 4, right? So pi over 2 times 4, comma 0, which would be pi over 8, comma 0. So pi over 8, comma 0. All right, so now we have our x-intercept. We have our 2 asymptotes. So our points in between, our halfway point between the intercept and the asymptotes, is where our other 2 points are going to go. So pi over 16, we're at 1, and 3 pi over 16, we're at -1. Okay? All right, so now we take a look and we are ready to draw our graph. So now let's draw, once again, try and do it the best we can. So coming down here, make a little bit of a curve, coming back down. All right, so something around that area for our graph, okay? So now, transformations. Well, a was 1, so we didn't have a vertical stretch or shrink, but b was 4. So all we had was a horizontal, and this would be a shrink by a factor of 1 over 4, okay? So that is how you can graph some tangent and cotangent functions.